Hi there and welcome back to the Good Tutor Premier Prep SAT course. And in this video, we're going to be diving into the Heart of Algebra subsection of the SAT Math section. And specifically, we're going to be taking a look at solving linear equations. Now, we won't be viewing word problems or the graphs of linear equations yet because those will be in subsequent videos. This video was merely an introduction to the skills needed to solve linear equations. So the main skill that's going to be needed to be successful on not only the Heart of Algebra, but really all of the SAT Math section, with and without calculator for that matter, is going to be the skill of isolating a variable. Do you know how to get an unknown value, a variable, alone? And we do this to solve an equation. If we can get it alone, and typically that value is x, if we can get that variable alone, we now know what that unknown value is equal to in terms of all of our other values. Now, there are a few things we have to do, though, in order to solve or isolate a variable. So here, let me show you with an example. This first example that we'll use is 3x plus 2 is equal to 8. And in this example, our variable is x, or our unknown value. And now we'll try and use the other numbers in order to solve for that unknown value, to give it a value, a known value. So I always like to tell my students that we have to begin with a number that is furthest away from x, yet on the same side of the equal sign when it comes to getting x alone. In this case, that would be 2. And as I've written here on this first bullet point, we have to use the opposite operation to move numbers to the other side of an equation. So the opposite operation of the plus 2 that exists now would be to minus, or take away 2. Now, we can't just do it from that one side. Every operation, as I have right here written on this second point, every operation that is carried out on one side must be carried out on the other side, or must be carried out on both sides of an equation. This allows us to keep the equation equal on each side of the equal sign. So if we subtract 2 from both sides, 3x will stay the same. So we have 3x, 2 is now gone from the left side, is equal to 8 minus 2 was 6. Now, only 3 and x remain on the left side of the equation. Now, the current operation being done between those two values is multiplication. So the opposite of multiplication would be division, which means we will now divide both sides of the equation by 3. 3 divided by 3 simplifies to 1x, or just x, equal to 6 over 3 rather, which would be a whole number 2. So x is equal to 2. Of course, we can check that by plugging it into our original equation. 3, with 2 substituted for x, as we solve for, plus 2 is equal to 8. Well, 3 times 2 is 6. Added to 2 more would be 8, which is true. All right, now we'll try a slightly more difficult example. All right. In this case, we have x plus 45 is equal to 90 plus 4x. All right. Now, in this instance, we have x on both sides of the equation. And what we'll want to do is get x to one side of the equation. So in this case, I will actually bring this lone x over to the side of 4x. Since it's currently a positive x, I'll have to subtract x from both sides. This will leave me with 45 is equal to 90 plus what is now a positive 3x after taking 1 away from 4x. From this point, I begin with the thing furthest away from the x, yet still on my same side of the equation, which would be 90. I subtract 90 from both sides. I'm left with negative 45 is equal to 3x. From there, I can divide both sides now by 3. And 45 divided by 3, or negative 45 divided by 3, would be negative 15 is equal to x. And that is our final answer. Now we'll view slope-intercept form, which is the most common form of linear equations that you'll see on the SAT. You may have seen this before, this famous y equals mx plus b equation, but now I'm going to tell you what each component of this famous equation actually means. X and y are coordinates of a point. So if we were to graph a particular line, any points given x and y value would be able to be plugged in to the slope-intercept form in the places of x and y. M, the m value is known as slope. And this will tell us how the line moves. Is it increasing? Is it decreasing? And for either, how fast is it doing so? And lastly, that b value on the end is known as the y-intercept. That y-intercept value tells us where the line will hit the y-axis. And if you'll recall, on a coordinate plane, the y-axis is the vertical axis. So that b value will tell us where, either positive or negative, our line first intersects the y-axis. All right, and that's about it for this video. Up next, we have word problems regarding linear equations.